In this section, we'll take a look at the Configuring and Monitoring IPv6 objective of the JNCIS Service Provider exam. We'll examine IPv6 interface and static route configuration, and basic dynamic routing with ISIS and BGP. For more detailed coverage of this objective and more, please check out the JUNOS Intermediate Routing course. In this video, we're going to take a look at the basics of IPv6 configuration. We're going to be adding IPv6 addresses to R1's interfaces facing R4 and R3, and we'll also configure a static route on R1 facing into R3's loopback address, specifically his IPv6 loopback address, so this address here. And we'll explore some basic operational commands whereby you can interact with IPv6 routes and the IPv6 neighbor discovery cache. We'll then follow on from this video with a later video where we will enable dynamic routing protocols for IPv6 on R1. We'll enable BGP and ISIS for R1, completing this overall routing topology. But for now, let's just get down to the basics of IPv6 configuration on R1. Before we do so, let me just mention that, as with other videos, ahead of time, all other routers in this network have already been fully configured for IPv6. So we're on R1 now, and we need to enable IPv6 on these two interfaces, on the R3 and R4 facing interfaces. Just have a look at the configuration as it stands. We've got family INET addresses configured, but we haven't got any family INET 6 addresses configured. So this is what we need to add first off. So we're configuring an address on the R3 facing interface. And we're configuring an address on the R4 facing interface. So let's commit this configuration. And let's now see, can we ping the remote end of these interfaces over IPv6? And to ping with IPv6, you can use the same ping command as you would for IPv4. There we go. So we can ping R3. And we can ping R4. And just like you would check the ARP cache for IPv4 addresses, what we can also do here is we can check the neighbor discovery cache for IPv6 addresses to see that layer 2 to layer 3 mapping. And this is what the neighbor discovery cache looks like on an IPv6 enabled router. We have our IPv6 addresses and the MAC addresses that they are linked to. So this is immediate connectivity to our next most interconnected neighbors. How do we configure routing on IPv6 devices? Let's first have a look at the routing table as it stands. So instead of looking at inet.0, we're now looking at inet6.0, which is the IPv6 master routing table. And we can see some local addresses, but not much more. These FE80 addresses are your link local addresses that are dynamically configured on every IPv6 enabled interface, and they're used for local communication, so communication that's only between you and your immediate most neighbor. Some routing protocols use these addresses for communication, for example. And then we have the IPv6 addresses that we have just configured. We've got our subnets, and we've got the specific IP addresses, the /128s, that we've configured on our local interfaces. And then we don't have much more in the routing table. So let's add a static route to R3's loopback address. So configuring a static route with IPv6 is much the same as configuring a static route for IPv4. The one main difference is that you have to specify rib inet6.0 in your command. So here we're specifying routing options, rib inet6.0, static route, then the destination network, and the next hop that we're associating that with. So let's apply this static route now. And we can check to see that this static route has populated the routing table. And it has. So can we now ping R3's loopback address? Yes, we can. So these are some of the basic operational commands that you can use to interact with IPv6 and configure IPv6 on interfaces on a Juniper device. In this video, we're going to take a look at dynamic routing for IPv6. We're going to continue from where we left off in the previous video, and we're going to deploy IPv6 routing for this network topology. And as with other previous videos, all routers apart from R1 have been configured. R1's configuration is much as we left it in the previous video. It's just that we've added a IPv6 loopback address as well. And in this video, what we're going to do is we're going to enable an IGP for IPv6. In this case, we will use ISIS. And we will also configure IBGP for IPv6 as well. So we'll configure an IBGP mesh for IPv6 on R1. And we'll see how both of these protocols advertise IPv6 routes on R1. So let's now turn and start configuring. So you see we're on R1 now, and you see that I've configured a loopback address ahead of time. You see also that we actually have ISIS routing configured ahead of time. This is because just to enable IPv6 support within ISIS, you don't need to do anything different to enabling IPv4 support at all. When you start adding IPv6 addresses to your interfaces and your loopback, they're going to be automatically carried in ISIS. If your IGP was OSPF, you would need to add more configuration. In fact, you would need to add a new protocol. To carry IPv6 routes within OSPF, you need to enable OSPF v3. But for now, let's just focus on ISIS. So let's have a look at the routing table as it stands first off. And you see we've got some link local addressing. We've got some of the local addresses that we've also configured ahead of time. We activate ISIS. So this configuration is no different to what you would have supporting IPv4. So let's just have a look at inet.0 first off. You can see we have IPv4 routes carried as we'd expect. We have a look at inet6.0. You can see the same is going on within our IPv6 routing table. We have all of the loopbacks within our network carried within ISIS. And this is exactly as we'd expect. So as you can see, one of the big benefits of deploying ISIS in your network is that it's very easy to have IPv6 support enabled with an ISIS speaking network. So we've quickly configured an IGP. How do we configure BGP? You configure BGP for IPv6 in much the same way as you would IPv4. You can configure BGP using completely separate neighbors, and that's what we're going to be doing in this case. Or if you wanted to, you could add the IPv6 address family under your existing IPv4 BGP neighbors. So as I mentioned, we're going to be enabling a separate IBGP mesh for IPv6 compared to our IPv4 mesh, and that's what we're going to do now. See that we have our IPv6 loopback address specified. We're doing next top self exactly the same as we would for IPv4. And we need to specify all of our neighbors. So we have our IPv6 full mesh group configured. Let's apply the configuration, and then let's have a look at our BGP neighbors. So you can see our IPv4 neighbors that were up and running ahead of time. These are the IPv6 neighbors that we've just configured, and they will be coming up soon. We just need to give them a little bit of time to establish, as this is a virtual system. And there we go, they are all up and running. So you see the output is much the same as it was with IPv4. We have our neighbor IP address. The big difference here is that because it's not an IPv4 address family, it's listed underneath the neighbor rather than being listed kind of next to the neighbor in the same line. And if you want to do a show neighbor on a IPv6 speaking neighbor, it's exactly the same as with IPv4. You just highlight the neighbor's IP address and you just do a show neighbor on that IP address, and you get all of the exactly the same output as you would. You just see that we have different address families enabled and supported. Finally, let's have a look at our routing table now. And there you can see we are learning the loopback addresses of those eBGP speaking devices across our newly created iBGP mesh. And the dynamics of this are exactly the same as with IPv4.